Hi, welcome to This Is My Architecture. My name is Andrea, and I'm here with Khozaima from Biogen. Hi, Khozaima. Welcome.
Hi, Andrea. Thank you for having me.
Tell us a little bit more about Biogen.
So, Biogen designs and discovers therapies related to neurological and neurodegenerative diseases. I'm a part of the cloud team, solutions architect, responsible for designing and deploying applications to the cloud.
Oh, very nice. So, we are here today to talk about centralized logging. And I can see here on the board many different services: EC2, CloudTrail, Lambda, S3, Elasticsearch. Tell us about this architecture.
Sure. So, the solution that we're looking here is basically a centralized logging solution. We've got individual accounts streaming logs to a central account. Uh, Most of it is serverless, and we achieve this by not installing any additional agents within our environment.
Okay, very interesting. So tell us a little bit about the logs that you're collecting. What logs are you collecting, and how can you describe how you're collecting them?
Sure. So the logs that we're looking at is basically network log, infrastructure logs, and application logs. We're using CloudWatch, CloudTrail, and VPC flow logs to have visibility into our accounts, from the individual accounts into a central account.
I see. So I can see CloudWatch, CloudTrail, flow logs, and these are where the logs are collected from. So how do you make sure that these logs, they all are different formats? How do you make sure it's all single unified format?
Sure. So the CloudWatch, the CloudTrail, and the VPC flow logs, they push data to a Kinesis firehose, and from Kinesis firehose, the data gets pushed into Lambda. The Lambda then is pushing the logs to a centralized S3 bucket.
Okay.
So we're using this Lambda for two different purposes. The first one is making sure that we convert logs from legacy systems into the right format that we need in the centralized storage. The second one is a lot of these applications have a lot of data that we wouldn't require for troubleshooting. So we use that Lambda to sort of make sure that we only get the data which would be actionable and which would be critical in the centralized storage.
Interesting. So also you mentioned application logs. Now, can you be more specific? Which applications is the target application? How do you go about to collect those specific application logs?
Sure. So we've got different type of applications for this architecture. Say if I have a web application deployed to this EC2 instance here, right? This web application pushes logs to the cloud through the CloudWatch agent, and CloudWatch would then fit into this sequence and finally push it to the S3 bucket that we have. So using the centralized account, we would be able to have visibility into the application logs running into this individual account.
I see. So you walked us through kind of the logic of how you go about, and you also mentioned CloudWatch agent. I'm just wondering, there's many choices there. You can use Kinesis agent. Why did you use CloudWatch agent and not Kinesis agent?
That's a good question, because Kinesis firehose being here, that would be the obvious choice. But back then, when we designed the solution, the Kinesis agent for Windows was not available. So that's why we went about using the CloudWatch agent here. The other advantage of using CloudWatch agent is it gives you visibility into other operating system level logs as well. So in case if your application is really critical and you need visibility into that, you could use the agent to push it to the centralized storage that we have there.
I see. So very interesting. So you're getting detailed information and you're passing that on, unifying that with the Lambda where you get it in the right format. And then I can see S3.
Yeah.
Is S3 your centralized storage then?
Yep, that's correct. So the S3 bucket that you see here basically is accessible to all the accounts within an organization. So all the accounts would be pushing all these infrastructure application network logs to that centralized S3 bucket.
Okay, so some of our viewers may say, why did you use S3 and why not just push that to the back end, right? Because I see Elasticsearch, Kibana, you could probably push that directly to these components. Why did you use S3?
Right, so looking at the flow of the design, it would make sense directly pushing logs to Elasticsearch. But what we wanted was having the flexibility to use a different visualization platform at any point in the future. So we could, at any point of time, use a different visualization platform to point to this S3 bucket and start generating a dashboard. Having said that, we wanted scalability, encryption, and lifecycle management across our logs. So we didn't want to store logs where we would run out of space, right? So that elasticity is what we use S3 for. Yes. Encryption, we wanted to make sure that the data that is resting there is encrypted at rest. So that, again, fits our design criteria. And we wanted to make sure that we have all these logs we have a life cycle management policy set across all these logs. So in case if you want to go back in time, we could still have access. So S3, these were some of the design considerations for using S3 there.
Okay. Yeah, very interesting to hear kind of unlimited scale and the lifecycle policies and as well as encryption. You're using a Lambda here, you're pushing the data back to Elasticsearch. Is this kind of invoked as data comes into S3?
Yep, so as soon as the logs from here come into S3,
Yeah.
Lambda triggers and pushes it to Elasticsearch. So what the logic around having that Lambda over there is getting all this input data from S3 and ingesting and pushing it to Elasticsearch.
So the data now sits here, meaning the logs, right? How do you go about to analyze the logs and what exactly are you analyzing?
Sure. So once it's in Elasticsearch, in case if there's an application downtime here, we would be searching for the application name as a keyword. As soon as we do that, we get a complete visibility into what exactly is the network infrastructure and the application. What's the state? What is the VPC, CloudWatch, and CloudTrail state like for that application? So just by the search of a keyword, we will be able to see what exactly caused a downtime for this application resting here in my EC2 instance.
Oh, very interesting. In the sense that it helps you troubleshoot and finally find a root cause. Now, before you move to this architecture, which is very neat, how did you go about to do analytics on logs?
Sure. So before this, like in case if we had an application downtime, since we've got multiple accounts, we would have had to first locate which EC2 instance is the application deployed to. Once that is identified, we have to locate which account does that EC2 instance belong to. We then SSH RDP into this EC2 instance and then look through the application logs and then correlate that with the VPC and the CloudTrail logs and then come to a conclusion what is causing a problem. So pretty tedious and time consuming, but that was what was used in the past.
Okay. Now I can see that you have individual account here and centralized account. I suspect that individual accounts means this is one unique account. How many accounts are we talking about here?
So we are talking about hundreds of accounts and hundreds of EC2 instances as well. So this setup that you see here is within one of our accounts. We have a similar setup in multiple other accounts. So all of this collectively comes and they push data into this S3 bucket, which is a centralized account there.
Okay, so you can scale across hundreds of accounts. Before we start, you start drafting this and kind of thinking through scalability and making sure it's highly available. How did you incorporate those design principles into the architecture?
Sure. So scalability was an important design consideration here, and we use S3 here, which is basically unlimited storage. And most of the other components that you see here, Kinesis, Firehose, and Lambda, also scales in demand. So as our workload increases, it would start scaling as per that. From an availability point of view, we have most of this is serverless, so it takes care of the replication and redundancy by default. Also, there wouldn't be any need of a scheduled downtime or a maintenance too.
So you're taking advantage of the serverless, the benefits of serverless with, making sure it's scalable, but also not much time for maintenance. This is really exciting. I'm really happy that you walked us through. We talked about, leveraging CloudWatch, CloudTrail flow logs to collect logs, and then using Kinesis, Firehose, and Lambda to literally make it in the right format and making sure you have the relevant data to centrally store it using lifecycle policies and making sure it's encrypted, and also making it also accessible for users to use their own customized dashboards. And then invoking a Lambda function that would then push it to the backend analytics like Elasticsearch and Kibana for troubleshooting and root cause analysis. This is really exciting architecture. Khozaima, thanks for being here and presenting this. And I also want to thank our viewers for watching this.